Morning to everyone. Just going to take a few minutes to welcome you before I turn it over to Dr. Rice, Russ College. Just wanted to say that you are participating in a wonderful speaker series event co-hosted by Russ College and Illinois Tech College of Computing. And if you have questions, we'll check the chat. If there are any technical difficulties, let us know via chat as well. And Dr. Rice?
All right. Well, good morning, everyone, and welcome. And let me say that I think this is a transformational collaboration between Russ College and Illinois Tech. We certainly want to thank Trustee Keithany Glass. When a board member says, hey, there is an initiative, you might want to consider it. That really doesn't mean think about it. It says do it. And we certainly are thankful to him for just his insight and foresight and relationships with you all to make it, to ensure that we made it to this point. So Erica told me to keep it brief. That's Erica spelled with the K and not a C, as she reminded me one morning when I was on the treadmill. But let me go through the people who, and I think the brilliant folks who we'll hear from today. First and foremost, Shlomo, my friend. And all of our panelists have very distinguished pedigrees. He is right now serving as the chair of Illinois Tech's Department of Computer Science and the founder of the university's Master of Data Science program. So you know that we're listening to someone who is an expert in the field, went to Carnegie Mellon, Yale, is also is a Fulbright postdoc. And from what I'm seeing from his very distinguished bio, his research focuses on developing computational methods for style-based analysis of natural language using machine learning and shallow lexical semantic representations, exploring applications in intelligence analysis, forensic linguistics, biomedical informatics, and humanities. Now, let me tell you all, I'm a historian. So this jargon is exposing me to a whole different world. And let me, so he'll be our moderator for the day, and I think a very capable and able facilitator for this discussion. We have four more panelists, all with very distinguished pedigrees. And Dr. Zing, maybe if I'm incorrect, I'll let you correct me when it's your time to speak, or you can correct me now if you so choose. But a PhD in computer and information sciences from DePaul, and of course that's in Chicago, has been very active in his professional services and was engaged in the organization of conferences related to the area of user modeling and recommender systems. So let us give a virtual high five to Dr. Zing for being willing to serve on the panel. Let me also introduce you all to Professor Glavich, maybe. Hey, I got the thumbs up, so that means that I'm doing an amazing job. He's an associate professor in the Department of Computer Science at Illinois Tech. His research spans several areas of database and data science, including data provenance, data integration, query execution and optimization, uncertain data, and data curation. He strives to build systems that are based on solid theoretical foundations. Again, solid, this whole panel is solid. Let me introduce you all to Professor Rich. He teaches computer science and mathematics here at Russ College and has been with us since 2000. He also teaches physics, so we believe in cultivating faculty to teach across the disciplines. His interests include computer programming, simulations, and all things science. Last, but certainly not least, Dr. Dean earned a PhD in applied mathematics from Illinois Tech in 2015 and is currently the program director for the Master of Data Science program and senior lecturer of applied mathematics at the Illinois Institute of Technology. His research interests include, or lie rather, in computational mathematics, function approximation, computational complexity, modeling and data analysis, statistical learning, data mining, and machine learning. Again, I may be the only person on the call who has a background in history. So I'm on the humanities side. But again, this conversation is just another reason why we are showing that both areas, certainly this area, is necessary and beneficial to what we're trying to do if we are going to have a future forward academic philosophy. So I will now defer to my good friend Shlomo if Ms. Burke does not have anything else to say at this time, and I will be quiet and take a whole lot of notes and likely go to a dictionary if I see words that you all discuss regarding the sciences that I haven't seen before.
Well, thank you so much, Dr. Rice.
Thank you very much, Rolandus Provost Rice, for that wonderful introduction. And I must say that I feel very fortunate that I'm not introducing you, because if I was going to list all of your qualifications in history, my tongue would be tremendously tongue-tied. So thank you very much for that. And also thank you very much for spearheading this wonderful collaboration that we have here. And I think collaboration really is sort of the watchword here of what we're doing, collaboration between our two institutions, collaboration also, I mean, we're talking about data science. Data science is inherently a collaborative activity. It's collaborative across technical disciplines and collaborative between technical disciplines and non-technical disciplines, as we'll talk about. The ability to bridge the technical and the non-technical is fundamental to the practice of data science. And I think that, as we talk with our panelists, we will see, how this comes out. And this kind of collaboration, teamwork, and partnership is really fundamental to what we do in data science and what we do in the academy, looking, as you very aptly said, looking forward thinking, forward moving. We have to look towards collaboration, to breaking down silos, breaking down barriers, and finding ways better to work together across disciplinary and institutional barriers, and move towards a collaborative and future. So to talk a little bit about data science, I just want to give maybe a few words of introduction, and then turn over to the panelists and get some stimulating discussion, maybe a little bit of debate even. To bring some interesting ideas out. The question is often asked, what is data science? And if you ask 5 experts, you'll usually get about 8 or 9 different answers. If you read different publications, you'll get a similar number of different answers. But I want to suggest an answer that I think kind of encapsulates all of them. And I think that what data science is can be encapsulated in a single word, which is sense making. What data science is all about, it's all about making sense of a complex and fast changing world to help decision makers get a clear picture of where they are, where they're going, and how they need to respond and how they understand the complexities of their situation clearly so they can better deal with whatever they have to deal with. What exactly that sense making is in any particular situation will depend to a great deal on the challenges that the decision makers are facing, the kinds of questions that they're asking. But what the data scientist is meant to do is to make sense of the decision maker's world for them using empirical data by collecting it, analyzing it, visualizing it, explaining it, telling stories that are well grounded in the data, and making things clear. So the data scientist is a technical person. The data scientist has to know how to do statistical analyses and build computational systems and collect data and do all of these, things with all this fancy jargon and stuff. But the data scientist also has to know how to talk to and understand people that are not technical and understand the non-technical questions, the human element, the organizational element, the business questions. Because otherwise they're not really going to be making sense of anything. They're just going to be solving technical questions. One of the things that I tell our data science students repeatedly is that a real data scientist is not somebody who the CEO or whoever comes to them and says, I want you to do this analysis, and then they go off and do the analysis. What a data scientist has to be able to do often is the CEO comes and says, I'd like you to do this analysis for me of the data. And then they say, well, what's the problem you're really trying to solve? And then they understand the problem that they're trying to solve, and they say, well, the analysis you asked me to do is not the right analysis. Let me give you a suggestion for what you really want me to do and to solve your real problem. Because the real problem is never a technical problem. The technical problem is an attempt to solve the real problem. And the data scientist has to help the decision maker understand their real problem using the technical issues and so forth. If I could ask everybody to mute, please. I apologize. So that's what data science is really all about. And it's that merger, that collaboration between the technical and non-technical that, for me is fascinating thing about data science. And I think it's one of the reasons why I think data science is part of the way of the future. As we're moving to a future of more collaboration, more interdisciplinarity, and figuring out how to do this in the academy and beyond. And with that, what I'd like to do is I'd like to ask each of our panelists to just say a few words about data science, about their involvement in data science, about their view of data science, sort of as a kind of an introductory stage setting, as it were, and then we'll start to stimulate some discussion. So I'd like to ask, if you could start with Boris, if you could say a few words.
Sure, happy to do that. My involvement, what data science is, I think you summarized it very nicely, right? So since I'm coming from a background of databases, my interest in that is often more on the data preparation and side and analysis side. And since I'm also working in provenance, which explains how outcomes are derived. So I'm also interested in the explanation side, how do we explain the outcomes that you get of a data analysis process? For example, you build your machine learning model and you're trying to understand why you get certain results or why the result is biased against certain groups, things like that. So to basically just add to that, what Shlomo said, essentially, right? So from a technical perspective, right? So data science often involves machine learning at the end to do the analysis and then doing visualizations and querying to interpret the results, as well as a lot of data preparation. And that often takes the largest amount of time. And it's the least standardized of the techniques, right? So machine learning, we have a good, of course, we are still improving the algorithms that we have and the models that we use. But right, in terms of data preparation, it's often much more manually because you need to find the right data sets. You need to understand the issues and quality issues and problems with the data set and how to work around them. And so, yeah, so I just wanted to add that part to it. Essentially, it's not contradicting what Shlomo is saying, just expanding on one of the aspects that I'm particularly involved with.
Great, thank you. Tim?
Okay, good morning, everyone. I'm Tim Rich, and I teach bits and pieces of data science in the computer science classes I teach, but I'm more of a data science hobbyist. I write programs and make models, and I consider data science to be the tools I need to make data-driven decisions. Okay. Statistics, computer programming, what you might call big data, just tools I need to make decisions.
Great. Thank you very much. Yuhan? Is Yuhan there?
Yuhan is muted.
Ah.
Yeah, thank you. I cannot unmute myself. Yeah, thank you. Good morning. So actually, I'm from mathematics, so maybe I'll talk a little bit more about from the mathematical perspective. So actually, for me, I really think Boris mentioned one thing about the data quality. That's very important. Especially right now, everyone can access a large bunch of data sets. So you can just access, you can Google it, but then how can you choose the data you really want to operate? How to get all the aggregation information you want? That's very important. And also, I think maybe from the statistical perspective, we also want to design our own kind of survey. If you want to investigate one problem, then maybe you want to design your own survey. So which kind of question you should ask? And also, of course, when we get this data science model, we want to do some prediction. Of course, we can use that. But then after several years, we need to consider how should we calibrate this model? It cannot always use the same thing for all the kind of time period. You need to do calibration. That's very important. So that's where the statistics canning and math canning. So yeah, I just want to mention these two parts. Thank you.
Thank you. We're getting a sort of a much fuller picture now with all the different parts sort of filling in. Thank you. Yong.
Yeah, hello. So my name is Yong. I'm currently the director of the data analytics and data science program in the ITM department. And previously I was a data scientist at Pandora, which is a music streaming company actually, okay? So data science, in my view, it brings different technologies, statistics, data mining, machine learning, artificial intelligence, so that we can work together for people to understand the data, make predictions, discover more insight or the patterns in business. And eventually we would like to use the data science technologies to, let's say, improve business intelligence, bring more profit to the company or something for that, okay? But with the advances in machine learning and artificial intelligence, in this case, there's different focus. I mean, when different companies mention the data science, they may have different focus. Okay, for example, in some companies, they may focus on just applying data science technologies to clean the data, try to find the patterns. But in some other companies, they would like to use data science to develop more effective algorithms. So it's maybe a more research-focused company. So I mean, the definition of the data science or the focus of the data science may vary from company to companies.
That's right. Thank you very much. So it definitely, we hear how there are certain constants or similarities between the practice of data science in different situations, but also a lot of variation in terms of the focus, in terms of how research oriented or how operations oriented different organizations may be. Let me ask, let's start actually. Yong, can you say, from your experience in industry, what would you say is the best way, for if a company wants to say get into data science, how would you go about building up a data science capability? What do you need in order to build up data science capabilities?
Okay, so first I want to point out that many companies have job position like a data scientist, but the specific job scopes or job responsibilities may vary from company to companies. So just give you some example. Let's say, as a data scientist at Pandora previously, actually this is a research position. So my major responsibility is to building, let's say, effective recommender systems. So I may use different machine learning or artificial intelligence to develop the algorithms, okay? But in other companies, let's say, some of my students graduate after taking data science classes from IT, they may find a data scientist position in a company, but this position is very different from research jobs. So in that case, they may want to just use the data science technologies to clean the data, pre-process the data, or use the existing algorithm to perform data mining, machine learning tasks. So in other words, they don't need to develop new algorithms. Okay, so in this case, we can simply decompose the job position to two categories. One is the research-focused ones, another one is the practical applications. Okay. So in order to have this position, let's say for practical applications, so in that case, you must have a series of the technologies, including statistics, data mining, machine learning, especially data pre-processing techniques, and understand how to apply how to turn up parameters in the data mining machine learning algorithms, and how to use the practical tools as a Python for the real world applications.
Tim, could I ask, in your experience in education, I mean, talking about all the various tools that Yang is talking about, in terms of how you would educate these sorts of data scientists to learn the various tools and to make sure that they can use them in application, would you what would you add here, or what would you say in terms of the best practices there?
Okay.
Well, excuse me. I thought that was for me. Anyway,
yeah.
I would have practicums set up to present to the entire class. I would give them a data set, say perhaps a biological data set, then show them how to clean it up and then how to analyze it.
Are there different sorts of tools that you would use for different kinds of data sets or different kinds of problems, or are they similar tools that would be applicable generally?
Different tools for different problems. Let's see. That's all I can think of right now. This is my first forum, so I'm kind of tongue-tied.
Perfectly all right. And so maybe Yuan, could you maybe expand a little bit about sort of the theoretical apparatus, because we want our data scientists to understand sort of the theoretical underpinnings of the tools as well. How much does a working data scientist, not necessarily the researcher, but sort of the operational data scientist, sort of need to understand about the the statistics or the mathematics behind sort of the tools that they're using?
So I think, like, for example, like if we do linear regression, we can get several like parameters. And then of course the data scientists need to know, okay, does this make sense? Just as you mentioned. So when we get the result, all the parameters, or do this parameter really have an important effective to this model? So how can we measure that? Or like when we get the results, is this result really can used to do the prediction? So this is some like hypothesis testing inside in the statistics. We can do the checking for the parameters. So I think at least for data scientists, they should have idea about like probability, understand what is the random variables, like the normal distribution, the most general distribution in this world, and also like some like how to do the sampling distribution and some hypothesis testing inside. You need to know, does this parameter really important, or can I tweak that? Otherwise, they don't know how to explain. So you need to tell a story, but then you need to know what does that mean. So I think it's important to have some statistical background inside, but then you need to explore more, because for different models, then maybe you need to have a different kind of like a math background to explain that. So I just feel data scientists need to always be curious. You need to learn something new. It's always something new there. Yeah.
Yeah. So there's sort of a psychological prerequisite to being a data scientist as well. You have to have that curiosity, right? Yeah. I wonder, and this I guess is a general question for all of the panelists. One thing is that for data science, you have to be grounded in the data and what the data actually say. So you need the theoretical understanding and the understanding of how to use the tools to know that the story that you're telling is really based in realities, based in the data. But how do you explain that to somebody who doesn't understand the technical details? That's always a challenge. I'll open this up to all of the panelists to address this question. How do you do that? Does anybody want to take a crack at it?
I guess I can if nobody else jumps up, right? So that means you need to, right? Obviously, you need some communication skills, right? And that's something that is maybe I wouldn't just limit it to data science, right? So in computer science, it's also really important. You're building complex systems, and the manager will never be able to comprehend based on their technical background the complete details of how the systems work. So you need to kind of explain complex technicalities in an understandable way and abstract them to the degree necessary to help somebody understand what they are buying into, right? And I think that's the same with data science, right? So you have to be able to communicate correctly with people at their level. And that, you know, that can be taught to some degree, but that's also, I think I feel a very practical skill where you need to, right, essentially need the experience. Maybe through some internships or practicums, you could learn by being forced to explain it to somebody who is not from data science or /CS, let's say, right? Or mathematics and doesn't have the background, right? But I don't have anything else intelligent to say about that, I think.
Yeah, so I think you know I guess one question that sort of would speak a little bit to this would be, and maybe Young, you could speak to this, or Tim, you know, what is, you know, what's a day in the life of a typical working data scientist look like? You know, what do you do in terms of, you know, doing analyses, talking to people, telling stories, building PowerPoints? I don't know. Young, you want to?
Okay, so
give a little bit of a picture.
I think there's a two part. One is the data science task you have for yourself. Another one is the jobs to have communication with others. So take the first one, for example. Okay, so again, it depends on the task you want to solve. But I believe that most of the time in a data science task, you may spend on is the data pre-processing. Simply because without correct data pre-processing, you may not get a good result, even you use a very powerful model. Okay, after the data pre-processing, I mean, you may use existing models, you may develop new models to evaluate them. So, I mean, that's the basic, the major task by a data scientist. But again, when you try to communicate with your teams, even the person from other teams, just for example, like Pandora, right? So we have a weekly or monthly presentation to the people in the company. So these people may from advertising team or HR team, whatever. So in that case, you need to, I mean, communication skill, definitely that's very important. So another skill you may want to have is visualization. Okay, so you may want to use different figures, graphs, try to show the patterns you found in the data, and try to make sure everyone can understand that, even if they are non-technical guys. I mean, if you only show the result, I mean, these people from advertising team may not be able to understand that. But if you are able to show a good visualization figure, try to compare different groups, different patterns, usually it's more straightforward for people to understand that.
That makes sense.
Right.
Tim,
and if he,
yeah, go ahead.
Yeah, if he, right, and like coming back to what he said before, right, like in terms of that there's different types of data science jobs, right? It's a big umbrella, right? And so we have like more research-oriented jobs, and right, and also in terms of your daily work might look a little bit different than if you're in a more application-oriented, where it's like you just have to essentially produce direct consumption analysis for somebody. And also there's even more shades to that, I would think, right? So for example, if I'm taking the example of Uptake, which is this company that does data science for big machinery, right? Like Caterpillar and so on. And essentially they predict when should you replace parts in such a machine, so that you don't lose money if the machine is down, right? Which is more expensive than replacing the very expensive part, right? So this is also, right, this involves then not just, model building and data preparation and so on, but it also involves essentially deployment of the models that you have built and also building data pipelines, right? So they have to process large amounts of data. So even the people in the companies that are very data science focused have to have some basic skills in like dealing with Spark and so on, right? To deal with like querying that data and pre-processing it. And so that means for some of them, like the day-to-day is like depends, right? You either, if you're working right now on improving the models, then you might play around with Jupyter notebooks, but then when it comes to deployment, then this is put into potentially a different language and at least a different environment, right? So they don't do, right? So the Jupyter notebook is just a playground for them. Sorry, for anybody who doesn't know what that is, that's like an environment where you can intermix documentation, code, and results. So it's very convenient for like exploratory analysis because you can directly see the visualize your data, run models, and change this all very quickly with results being updated.
Yeah, I mean that gives a, you know, that's you know, the variety of different languages and tools that you might use for different purposes, as you say. You know, gives a nice segue into another question, you know, from the audience, which is, you know, what are the main languages and tools that are used, you know, both for, you know, in terms of languages, Python or R or stuff like that, that are used for data science, and what kinds of visualization tools are most used? I don't know if Tim, if you have some insights, or Yong.
Okay, so first I want to mention that data science is not new actually. Okay, so let's back to the old history. Actually, I think the first tool to be used to analyze data in the history is data warehousing. So data warehousing was developed actually for the non-technical guys in the company to analyze data and discover the patterns. Okay, but in nowadays, okay, so there's many tools. Some tools with the user interface, some tools you rely on the programming language, such as R and Python. Okay, I do notice that some audience ask question, which one is more popular, R or Python? So from my view, okay, so it's very difficult to find a job position in data scientist if you don't know how to use the Python for data science. Okay, why? Because so Python is open source, and they do have a large community with tons of the open source libraries to be used not only for the purpose of the data mining, machine learning, but also for visualizations. So in my teaching, most likely I rely on the Python, but I do give us introduction about the other tools with the user interface or not. But I do believe Python is a must skill, you know, for data scientist position.
Yeah, makes sense. What about visualization tools? I don't know if anybody has any recommendations for visualization tools that are good, because one of the important things, you know, when we're telling stories, sometimes those stories are visual stories. Picture is worth 1,000 words. At least, you know, a good picture is worth 1,000 words, right? So are there particular tools that are useful that people would recommend?
Well, to expand on what John was saying, like again, like what do people use? It's a lot of stuff is uses Python libraries again, because there's just a big ecosystem, right? So for example, just to throw out a few, like Matplotlib or things that are built on top of that, like Seaborn. Right, there's some more exploratory use of things like Vega and Vega Lite, which are kind of like visualization specification languages, but that's a little bit more exploratory, and I don't know about industry usage of that. Yeah, but yeah, so Python, there's a lot of Python libraries that allow you to create all kinds of different visualizations, and for R, obviously, there's also tons of stuff, right? Yeah. Or I don't know, but
yeah, there are also sort of WYSIWYG tools like Tableau or Power BI, which can be very useful for exploratory analyses.
Right, and which has the advantage that they're really fast, which is maybe a disadvantage of Python, right? So Tableau, actually, Tableau bought a database startup for an in-memory database system, so they have to speed up their visualization. So, right, so that means in Python, right, you're a little bit more limited. Of course, you can kind of pre-process things with like a big data framework like Spark or so, but
yeah, so I think we're getting some really good information, I think, and get good understanding, but maybe a little bit too much agreement among our panelists here. This is maybe a little bit too calm and happy. Let's see if we can maybe stir things up, and let's ask about the ethics of data science. So today with the growth of, powerful machine learning models, the growth of the importance of privacy issues. I mean, there's a lot of data science. I mean, we can do fantastic data science if we ignore privacy questions. We want to do face recognition. I mean, we want to do face recognition to improve security. Is that a good idea? Where do we stand on ethical issues, and how should we be educating our data science students to become ethical data scientists, but ethical and yet effective data scientists? Anyone want to grab that, or should I assign that question?
Well, as an educator, I think we should tell the students of the choices that are headed their way as they go out into the real world and start practicing. They're going to have to make some ethical decisions of their own, and they should have some warning. For example, there are some new medical devices being devised, brain implants that can cure depression. It's taking data science to design and build those implants, but not much is being said about what could happen if a device like that got suborned into some other task. But we could wrangle for hours on the ethics in data science. I just believe that we should warn the students, educate them about what's headed their way.
Right. So one thing is like, what do we think is ethic data science? And the other thing is the reality in the industry. So I think this is a good point. I mean, essentially what we can do as educators is to essentially make people aware of the ethical implications of these technologies, but then they will still have to face this decision because industry is not going to care, right? For the most part, they're just going to, right? If they can get the data from some user, if nobody's stopping them, they will get the data, right? That's just the reality based on what we see, right? And so that will also, we are unlikely to be able to change this as educators, right? But we can at least explain to people what the ethical issues are. Maybe some of them are not even aware of what results such a technology could have. At least they then they can decide, am I going to be willing to work for this company or in this position where I know I might have to do some questionable ethical choices, and some of them will still pick this because you get a lot of money, right? Or maybe they don't care. But at least they're not unwillingly making bad ethical choices.
Yeah, I mean, these ethical choices also sort of interact with regulation and regulatory regimes, and our students are going to be the future experts that are informing regulations or trying to influence regulations, perhaps, together, of course, with the big corporations. So how does that sort of feed into what we try to teach our students, or what we want working professionals to know and to understand about these questions? Yang?
I mean, first, there could be two stages we consider this issue. The one is about the data collection for that. Okay. Another one is once you have the data, how to utilize the data. Okay. In terms of data collection, definitely that's one part we need to pay attention to. I mean, if you use a special technology, for example, some websites try to use a cookie to collect user, let's say, browsing behaviors. So typically, I know many large companies, let's say Google, Amazon.com, actually block the usage of cookie because it may be a huge concern about user privacy. Another one is about data protection. So there's some kind of these special technologies. I mean, it's not related to data storage, but it's also related to big data computing clusters. Also, the most promising research direction is called federated learning, right? So that's some kind of way for us to protect the usage even the parameters or your models or algorithm, personalized information in the distributed computing. So that's a combination of the data science and the technologies in the computing.
And how should a working data scientist deal with a situation in which they may find themselves, working, perhaps for a large corporation? They discover suddenly that some of the practices of that corporation, whether in the collection of data in relationship to privacy, or the way that that data might be used, or the implications of the corporation's practices, might strike them as borderline or actually unethical. And what do we do about that? I mean, maybe this is beyond our ken, and we should be talking to ethicists and philosophers. But how do we think about that?
Well, I mean, obviously, the best thing would be if they whistleblow, but from experience, right, we know that whistleblowers are often just being fired, right? That's the reality. So, right, so I think it would be kind of even almost unethical for us to, essentially teach them good morals without kind of exposing them to how things work in the real world where they have to have a job afterwards. So even so morally, I would say it's obviously that they have to whistleblow in such a situation, but right, this can have negative consequences. And essentially, as long as there are no laws to protect people effectively from blowback from the company, if they, whistleblow about the companies, and as long as the companies don't have any severe consequences, right? Because right now it's not that there's, that there's no penalties for doing ethically bad stuff, at least in certain degrees, right? So certain misuse of user information and so on, right, causes penalties. However, the penalties are so small or so rarely enforced that for a company, it's just a choice of, well, we can continue this practice and make much more money, or we could comply with this requirements, and but we are only going to pay this much in overall, if at all. So there's no essentially strong incentive unless the penalties are higher or they're enforced stronger, right? So that's a challenging issue. How should we advise people, right? Should we tell them, right, do the morally right thing? But we should at least be fair and tell them also that this can have negative consequences, right?
Yeah, I think it's a systemic problem. I mean, as you say, when you have large corporations and there are large amounts of profit to be made, and the penalties are not necessarily all that large compared to the potential profits, it's very, very difficult for any regulations to have any sort of traction, and for individuals to be safe in dealing with this. I mean, one thing is that those of us who are tenured academics have a somewhat safe platform to be supportive in some ways, although there are limits as to what we can do. So we need to be raising our voices and trying to push the needle on these issues as well. One of the questions in the chat is, are there any groups that monitor the ethical use of data science? I think that's an excellent question. I think that there are some groups that are attempting to do so, but I don't know if any have really gotten any big traction, because none of them actually come specifically to mind, although I have some vague memories of having heard of some. Do any of the panelists know of any in particular?
So in Europe, we have GDPR.
Right.
So GDPR is very popular, right? But in US, I'm not very sure whether there's standard for that.
Right, and so what we can help as researchers perhaps is like with GDPR, causes big challenges for companies, because they have to, it's not trivial for a company to delete all of the information related to a user. If you just have to delete the information that the user submitted, that's easy, right? You can keep track of who submits what, and then you delete it. So, but right, the company typically then has derived information that is based on the user's information. So for example, if the user's data was used to build a machine learning model, does this have to be retracted, and the model has to be adapted to exclude this user's information when we delete the user. So, but as researchers, we can perhaps help to some degree by developing efficient techniques because then essentially the trade-offs become different. If it becomes easy for a company to comply with GDPR rather than pay penalties for not complying, then right, that might help a little bit shift the scale in the opposite direction.
Yeah, another example, for example, one of my research topic is about recommenders system. So we try to collect the user taste data, for example, your previous purchase behaviors, your browsing behaviors, and try to model to guess or predict which item you like in the future. Okay, so in this case, there's many debate in this area, but in our area, we try to build models which can explain why we recommend this item to you, to let the user understand, okay, this is safe for user to share their data with us. Okay, so this is another way actually try to reduce the conflicting between the user privacy and data usage in the data mining machine learning models.
Mm-hmm.
Right, so the issues are obviously mostly not technical, but techniques can help at least to some degree to identify when, for example, also some techniques I've seen is like we can, if a user exposes some information, the problem is that, right, so there's a lot of related information that they might not be aware of that can be inferred based on just the information they release. So for example, if they release like where they are living and a few other factors, they might actually write many more information that is more they want to keep private could be inferred. And so you can kind of reason about whether a model can, right, whether essentially releasing a factor would be able to let a model predict something else based on you. And so these things can help perhaps, or what Yong was mentioning, having like computations where the company itself essentially doesn't directly see the user's data. We're just submitting, we're doing a computation that is hidden from the participants, right? And that's of course a very good idea, but first it needs to be applied. And also the problem is often computational efficiency. Many of these techniques of federated computations where the parties are individual are usually not trustworthy. Often you pay this with performance, right? Or with limited computations.
Yeah, no, thank you. I mean, as you said, I mean, the technical aspects of these solutions are really not the main. They're not the solutions themselves. The question is, what are the non-technical, political, social aspects that design, what the answers, how to deal with it, with the questions, and then the technical. So the technical aspects are in service of those social things, and so let's shift gears a little bit. As we're coming up against the hour, I think that we could easily speak for another hour, but we're coming up against the hour. So let's talk practicalities now. So the questions come in, and I think this is a fantastic question. If you come to a new data science problem, how do you go about starting to build a model or an algorithm for dealing with a data analytics problem? So you want to build a recommender system, or you want to build a predictor for some particular problem to help someone make better decisions, or to predict customer interactions so that you can give them better recommendations and get more sales. How do you start that process? What do you do? Who'd like to start? I'd like to hear from everybody.
I think we always have a real world problem first, right? So the first, usually using your mind, try to formulate the real world problem to a data science problem. Okay, for example, you want to predict that, say, in the Amazon.com, so what kind of the item you are going to buy? So in this case, you should translate this real world problem to, let's say, either a supervised learning or prediction task. Then you go further, you go deeper. Let's say which kind of the model it is, what kind of data you have. Then furthermore, you can also read the articles about what else, I mean, what are existing techniques, okay, other researchers have done, okay, then you can propose your own ideas or whatever. I mean, you don't need to build the algorithm from the beginning. I mean, you may try to seek the relevant techniques, then try to give changes or modify existing models and develop your own.
I agree. Begin with research in your problem, and in the past 2 years, I have found vast troves of algorithms already made for particular types of problems. And there is an old computer science adage, you don't need to reinvent the wheel.
No, very true. Very true. Yuhan, anything to add?
I think like both Yon and Tim mentioned, so you can start from like some algorithm already like there, because like from the mathematical perspective, you always try to convert the problem to some problem you know how to solve. So that's the key idea. Then of course, but I think the other important thing is how can you access the data set? Like especially if you want to build some like kind of like recommendation system, then definitely you need to have a kind of a large data set. You can track like the history back, like for maybe not just like 1 year, maybe 2 years. You need to see the pattern there. So like the user's behavior. So that's why like if you can have this or data set access, then of course then you can start to maybe read some research papers regarding this part of the area, and then try to, of course, if it's better if you can try to make some improvements based on the current algorithms. But I think you can start from the simple one, just based on the algorithm already being built outside. Just use that first and then try to tweak.
Yeah, I think first you have to start with also figuring out, once you identify the real world question and formulate it as a data science question, then you need to find the data sets, right? And so that might mean collecting data, but nowadays at least there might be auxiliary data sets that you can get free access to, right? So for example, right, so let's say open government data, right? So if that gives you, for example, census information and information about things in the city that might be useful to your prediction task, right? That you don't need to collect yourself. But then you need to integrate this data and you need to understand it, right? So that will take time, right? And then maybe, for example, let's say you want to predict the safety of a neighborhood in Chicago, right? So you can look at the police data that is freely available, but you probably also want to look at other aspects, right? And so then you need to integrate all of this data together. You need to understand the data semantics, and that's also what Yong said, right? The data preparation in the end is like typically where you spend the largest amount of time on. If we take like a end-to-end data science problem where you start with a question and you don't have any data, you need to do all of the steps, right?
Okay, thank you. And I guess one final question here, and then maybe we can incorporate just some final thoughts as we sort of wind up. How do we incorporate or deal with questions of bias, whether bias in the data, bias in the questions that are being asked of the data, or potential bias in the decisions that might be made based on the data. How do we account for these? Any thoughts and any final thoughts about data science for everyone? Let's just go around. Yang?
So I think typically there's basically two solutions. The first one is data sampling, right? So if you get a small sample of data for data science, definitely there's bias, okay? But currently there's many big data technologies. You can perform data science models, evaluate these models on the big data. So potentially it's able to reduce the bias. So another solution typically is many debiasing technologies. Okay, so both in the research, also in the academia, so there's a very popular term right now. It's called fairness. Okay, so you are able to consider the fairness in your model and reduce the bias in your model. So even if probably they are the best already in the data, but you can use debiasing technologies. So try to reduce that. Okay, but I have to say that the bias is always a problem in your data you cannot avoid. But the only thing you can do is try to elevate that, but not to try to totally remove this bias in your model.
Tim?
I have a firm belief that when you're working on a problem, bring as many different minds and perspectives to the table as you can. It's when you have a vast difference of perspectives and experiences, it is easier to overcome bias in data and in your problems than if you were working on a problem alone.
Very wise words. Yuhan?
So I just recall like one story I read from the book. So like if you try to collect some survey, like you do it online. So you think you can do sampling, like, or you try to like email maybe different kinds of like people you try to do. But actually when you do that, you already exclude some people they maybe never want to like access the internet. They don't want to depend on the internet. So you already have bias inside to collect the data. So in my opinion, I think it's always inside the bias in the data set when you collect the information, when you try to do this or analysis there. But then I think just as you mentioned, we need to find some kind of like tool to to make this bias impact on the data set as small as possible. And also we need to like just think about like when we build a model, it can have the bias inside. So after maybe several months or like we need to do the calibration. We need to, based on the current data we can collect. So also it will have bias inside, but still that's the best what we can do. So try to do the calibration after that. Yeah.
Thank you. Thank you. Yes. And Boris?
Yeah, so just to add on to what everybody said so far, in terms of fairness, right? So there's a, to be honest, more challenging human side of things of how do we even define what is fair, right? And what is biased, right? So, and this has also then kind of translated into the technical perspective where people come up with this fairness metrics that can test whether a model is biased against a certain part of the population, for example, biased against the gender or biased against the race, right? And this different definitions people come up with, they're mutually contradictory. So that means, and they could make some sense in some domains. For example, we can require that, let's say it's about loan decisions. We want to have essentially people from different genders or different races have the same probability to get the loan, right? Is this fair, right? Because they also might differ in other aspects. So, right, there's other notions that try to say if they don't differ in anything else but the race, they should get the same probability. And even if we decide on something like that, it's still, the one issue is that the sampling can create the bias, but it can also just be that the training data is biased already, not just because of sampling, just because of historical biases, right? So for example, in terms of incarceration, there's, there has been the stories about this automated system that determines sentences, right? Prison sentences is biased, right? Because it was trained on biased data. So in this case, sampling alone might not be sufficient to repair the bias because the training data itself is already biased. Then you can still try to identify this bias and do techniques like deleting training data, trying to collect new data to combat the bias. But it's challenging. And also, again, it's not just a technical problem. The technical problem is maybe the lesser one, and that's already complicated.
Well, thank you very much, and I'd like to thank all of the panelists. I think that a couple of the themes that have been brought out here is, first of all, a lot of these problems you don't solve the problem, but you come up with an ongoing solution that you manage and you monitor and you watch. You don't solve bias, but you watch for the bias, you watch for the fairness, and you're constantly watching evolving and dynamic situations in data science. And also the technical solutions are not the solutions. The technical solutions are in service of the higher level solution, which involves the human element, the business element, working through those higher level questions, and that collaboration. And it seems like these are, perhaps the common elements that come out of the very different perspectives from our panelists. And thank you all for that. And I'd like to take this opportunity very much to thank Dr. Rice and Rust College for this wonderful opportunity, this wonderful partnership that we are embarking upon, Illinois Tech and Rust College. And I'd like to tell everybody, please, for more information, please contact us, iit.edu and rustcollege.edu. And I'd very much like to thank Mr. Keithney Glass for setting all of this up and bringing us together. This collaboration, and collaboration is the watchword of the day, of the year, of the decade, and of the century. So I'm very, very happy to be doing this. And thank you, Erica and Scott, for enabling all of this to happen, putting all of the pieces together. And thank you, everyone, for coming and attending and participating and asking such wonderful questions. We really appreciate this opportunity, and we look forward to hearing from you and for many, many more such events in the future. Thank you.